Okay, and here we have solving systems of linear inequalities. And our goal is going to be able to take three inequalities and graph them or more and determine a specific region with which solutions can exist within. Okay, let's take a look at this very first line. Y is greater than negative 3. Now, first things first, let me go ahead and draw an XY axis. Oh, that's kind of sloppy. See if we can do better. That'll do. An XY axis where I'm going to use blue for this line y is greater than negative 3. Now you'll notice there is no x term here. And since there's no x term, check it out. It's so easy. Since the only letter we see is y, we go to the y-axis, and it's negative 3. So I'll go down 1, 2, 3. And I essentially have to draw a line parallel to the x-axis so that it will never touch the x-axis. I also say it's a dotted line because it's greater than. And since it's greater than, we know we're going to shade above. Now remember, I like to use these sparse blue lines because we're going to look for the region where we have three different colors all overlapping. Okay, let's go ahead. I'll switch to this nice orange color here. And for our second line, we have y is greater than or equal to 4/3 x minus 3. Now I circle the minus 3 because that's our b term, and I know I'm going to go down 1, 2, 3, and coincidentally put my y-intercept right on that line that we drew originally. Now my slope here is 4/3, and guys, don't forget the m is the change in y over the change in x, or aka 4/3. So we will count up 1, 2, 3, 4. Sorry, that's 3 is the x-axis. So 1, 2, 3, 4, and of course to the right, 1, 2, 3. Okay, and hey, that's not too bad. Now from here, since it's greater than or equal to, and I'm stressing the or equal to, whenever it's or equal to, we know we're going to draw a solid line. And let's pretend it hit that point. Okay, and this says y is greater than, so of course we're going to say, yeah, y is greater than, it's going to be everything above that orange line. And hey, I'm not the neatest writer in the world, but this looks pretty good so far. Now let me go ahead and do this last inequality in purple. And in fact, let's go ahead and write it out here. 2x minus 4y is greater than or equal to negative 4. Now remember, in order to graph this, we have to first get the y value by itself. So we can subtract 2x from both sides. Those cancel. And I have negative 4y is greater than or equal to. Let's write the negative 2x first and then minus 4. Now from here, of course, we know that when two things are side by side, they're being multiplied. And so we'll divide every single term by negative 4. Now, some of you might be thinking, well, wait a second, Mr. Hastings. What about our inequality? And I'm so glad you asked. Remember our rule, whenever, I'll write it over here, whenever we divide or multiply by a negative, our inequality has to flip. And so let's take this greater than or equal to and rewrite it as a less than or equal to. Now from here, of course, we know a negative divided by a negative is a positive, and 2/4 reduces to 1/2x. Negative 4 divided by negative 4 will of course give us positive 1. So what is this going to look like? Well, we come up here to positive 1 in our nice purple color, and we are going to go up 1 and of course to the right 2, and we could even go up 1 more and to the right 2 yet again. Now from here, let's go ahead and draw this. Let's see. It's going to be a solid line because it's less than or equal to now. It's a solid line. And notice, because it's now less than or equal to, we have to shade everything below. Now it should be fairly obvious at this point where all of our solutions are. But just in case you're having a hard time seeing it, I noticed that kind of stuck in right here in this triangle, kind of stuck right here in this triangle. This is the only space where all three of our colors overlap. Okay, that is the only place where all three of our colors overlap. And since that's the only place where all three of our colors overlap, this is the only region with which we can find solutions. So for example, if we said, well, what if we went to the left one and down one? Yeah, we would say, you know what? One of our solutions can be -1, comma, -1. Let's go ahead and find another solution. What if we said we went to the left 2 and down 2? Yeah, we could say -2, comma, -2. What about, here's a question. What if we went to the left 3 and down 3? What if we were on that blue dashed line? I'll say it one more time. What if we were on the blue dashed line? Well, remember, guys, a dashed or dotted line is not a solution. So, in fact, 3 comma -3 would be not a solution. Okay, perfect. All right, guys, let's go ahead and take a look at one more example. Okay, here we are. And yeah, let's call this example 2. Now, you'll notice this one looks pretty hefty. We actually have 4 distinct, I'll say it again, we have 4 distinct linear inequalities. But let's go ahead and see what those look like. Why don't we start with the easy one first? You know what? In this nice red color, we have x is less than 8. Now notice there's no y value, so that means we have to go on the x-axis explicitly. 1, 2, 3, 4, 5, 6, 7, 8. And we're going to say, you know what? Since it's a less than symbol, it must be a dotted line. And what do you think less than would be right here? Oh, and by the way, it's a vertical line because since there's no y component, it can never cross the y-axis. So I draw it parallel to the y-axis. And of course, less than would be everything to the left. Okay. Perfect. All right, let's try another one. Let's go ahead and try this interesting, let's try this line right here. Notice I'm doing the easy ones first. Well, here in this blue, we have y is less than -2/3 x plus 2. Notice I'll start with my b term, that positive 2. And so we can go up to, put our very first point, and it's y is less than -2/3. That -2/3 will drop us down 1, 2 to the right, 1, 2, 3, down 2 to the right, 1, 2, 3. And since it's a less than symbol, well, of course we know we're going to use this dashed or dotted line. And since it's less than, we know we will shade everything below. Okay, this could turn out interesting. Let's see what happens. Okay, the next one, and I think this one's a little bit more subtle. The next one we have here is -x is greater than or equal to -1/3 y. Well, guys, check it out. We know from our assignments a long time ago, in order to get rid of a fraction, we just want to multiply by the reciprocal. So what's the reciprocal of -1/3? Well, it's going to be -3/1. But we should know by now that -3/1 is just times -3. Well, wait a second. Here we have a negative times a negative, which is going to give us a positive 3x. And don't forget, whenever we divide by a negative, our inequality flips. So this goes from being greater than or equal to being less than or equal to y. Now, the final thing, and what makes this so confusing, is that we never, ever, ever write it with the x term first. So we are going to put the y on the left, the x on the right, and check it out, you probably guessed it. If you flip the inequality, or the equation, the inequality, you have to flip the symbol as well. So that less than or equal to becomes a greater than or equal to, and ironically, it now kind of looks like what we originally started with. Notice there's no y-intercept here. It's like saying +0. So we can start right here and go up 1, 2, 3 to the right 1, and we'll have our solid line looking like this. Okay, notice it's also y is greater than, so here we shade above. All right, we have one final one. And I'm sure y'all are starting to see where this region is starting to take shape. And this very last one, why don't we do it in orange? And I'm going to kind of simplify as we go. Let me write y is greater than. We know negative 2 times x is negative 2x. Negative 2 times 3 is negative 6 plus 2x plus 4. And now all we have to do is combine our like terms. Oh, and wait a second. Negative 2x and positive 2x, those cancel, and negative 6 plus 4 will give us y is greater than negative 2. Okay, since it's y is greater than negative 2, there's no x value. We're here on the y-axis. We go down 1, we go down 2, I put my point. And remember, this line can never touch the x-axis, so it becomes parallel to it. And because it's greater than, we'll write that dashed line, and we'll wind up shading everything above. Okay. Now at this point, most of y'all can probably see where our overlapping colors are. If you're having a little bit of difficulty, remember, we can't go below that line right there. We can't cross that line right there. And we can't go anywhere above that line. And fortunately, our red shading is crossing into that, so that didn't really matter too much. So y'all can kind of think of anything that as this region expands this way, anything that falls in this region or this 4 colored shaded region, that's where all of our solutions lie. So for example, if you wanted to go way over here, we could call this point something like negative 12 comma 0. You know what? That would definitely be a solution. But what about something that's not in that quad shaded region? What about something like this, like negative 1 comma 11? Well, we know that that is not a solution. What about something way over here like a, I don't know, a 1, 2, 3, 4, 5, 1, 2, 3. Something like this, like a 5 comma 3. Well, it's also not in that quad shaded region, so that too will be not a solution. So the long and short of it is, for the number of inequalities that we have, our solution can only exist in the shaded region that is shaded by all 4 inequalities. Alright, thank y'all so much, and I will catch y'all in our next lesson.